So, hello students. We were studying about probability in the previous class. So, we will proceed ahead with the same concept. Random variable, that's what I was discussing. So, a random variable is defined on a sample space. Okay, and we have seen what does a sample space means. All right. So, here is an example for a random variable. That means let us take x. It denotes a random variable, and I need to define it as a sum of two fair dice which are rolled together. Okay. So the thing is, when I'm going to roll up the two dice, that means they are having six possibilities. Each of dice is having the six possibilities. So the total number of possibilities, as we know, is six into six. That is what? 36. Now, if I am asked here x equal to 2, that means what is the possibility that I am going to have a 1 on both the dices? That means this is only one of the possibility. All right. So the result which I am going to get here is 1 by 36. Now, same thing, what is the possibility that I'm going to get 5? So what are the possible combination on the both the dices? That means I'm going to have 1 4 or 4 1 or 2 3 or 3 2. That means I am having four possibilities. So the total number of outcomes are 36 and my possibilities are 4. So 4 by 36, that will be equal to 1 by 9. All right. So this is how it's a simple mathematics which we do apply in our probability. Okay. And let us take some more example. That means if we are going to suppose tossing a coin with a probability p for coming up heads after n flips. Okay. So n flips, that means either you toss the coin, you got head, that means success. In a one attempt you are success. For example, you didn't got the head, you got tail. Then again you flip the coin, then again you flip the coin, unless and until you are not going to get the result. That is your tail. So suppose we are going to toss the coin whose probability of coming is p. All right, so how to crack this problem? Here n equal to 0, that means we haven't tossed anything, so probability is obviously no, we don't have any probability is 0. Now, if we tossed n equal to 1, that means first time we toss and the probability of coming head is p here. All right. If it come, it doesn't come, whatever be the here the probability of coming head is p. All right. For example, we toss the coin for the two times. Okay, and why it happened for the two times tossing of the coin? Because for example, you haven't got the head in the first case, then for the second time you got the head, for example. So head after one tail, we are expecting that the first toss was a tail, so the probability of tail is 1 minus p. Why? Because the probability of head is p, so obviously the probability of tail is going to be 1 minus p, because we know that the probability exists between 0 to 1. Okay, so it's a overall probability p into 1 minus p. Now if you tossed for three times, okay, now this is your function, and n equal to 3, this is your random variable. All right, that means you are tossing the coin for the three times, and in the first two cases you failed and tail appeared. So the probability of appearance of the tail is 1 minus p into 1 minus p. And then in the third attempt, you got head. So its probability is p. So 1 minus p into 1 minus p into p, that will obviously 1 minus p square into p. And the n equal to small n, any number of attempts. Okay, so its probability will be 1 minus p to the power n minus 1. Okay, because first attempt we are saying it's p, so obviously your result is 1 minus p into n minus 1 to the power n minus 1 into p. That means head after n minus 1 trials. All right. Now, next, we have also gone through about the discrete random variable. That means discrete means something which is countable in nature. All right. So a random variable which is defined over countable items, countable values, that's called as a discrete random variable. And a continuous random variable is a variable that is defined over continuous values. So as I told in the previous class also, you have to keep in the mind what is discrete, what is continuous, what is categorical, because in our data set on which we are going to do the projects, okay, it comprises of these values only. And once you are able to understand that we are having a continuous, then you will be having an idea what kind of plots I can make for the continuous, what kind of plots I can make for categorical, what kind of plots I can make for the discrete values. So discrete values are those values, as I told, it's countable in nature. Okay. So for example, I told in the previous lecture also, if you are having a limit between 0 to 5, if I say give the discrete value, so between 0 to 5, the discrete value could be 1 or it could be 2. Okay, but there are no multiple values between the limits. That's something important to understand. Discrete is something I am having one value between an interval. That's discrete in nature. However, if I would say how many values are there between 0 to 5, if I say continuous, so there could be like 1.7, 2.1, 3.5, 4.2, 4.8. So there could be many values between an interval. So these values are said to be continuous in nature. Okay, so discrete and continuous, you should have a clear idea about both of them. Now next is cumulative distribution function, CDF. So it's a distribution function of a random variable which has been defined over the number b. Okay, and here b is lying between minus infinity to plus infinity. So any number, okay, between this limit, it's a real number on which my function has been defined for. So it's said to be CDF, that is cumulative distributive function. So FB, it's denoted by FB, and the probability that the random variable x is going to take place a value which is less than or equal to b is defined as like this: x less than equal to b. All right, so for example, if I'm going to consider two limiting values. Okay, this is the lower limit, this is the upper limit. For example, two values if you are going to consider, and this is your random variable x, and I'm saying my random variable x lies between a and b. So this is how you can define a cumulative density function, distributive function. Okay, p a x less than, okay, b. Okay, and its value is defined as fb minus fa. So you are going to put b in the function, whatever the value you are going to get, then you are going to put a into the function, whatever the value you are going to get, just subtract it. That is cumulative distributive function. Okay, and we have also seen various properties of CDF. That means if you limit to x minus infinity, it's 0. If you limit to f of x to plus infinity, I'm going to say it's 1. Okay, and whatever be the things between intermediate a and b, this is the relationship: fa is less than equal to fb. Okay, for the two different values a and b, and where a is less than b. These are few properties of CDF. Okay, so now the next thing is discrete random variable. So as discussed above also, discrete random variable is a random variable that is defined over countable values. Okay, countable. So the thing is, for discrete random variable, we would say probability mass function, PMF, probability mass function, and it defines a probability that a value of a random variable x is something like this: PMFA equal to Px equal to a, whose value in form of cumulative distribution, that is the cumulative distribution function for a discrete random variable, that's what I told above, is given as the sum of its probability mass function. Here it is, probability, that means cumulative distribution function can be expressed in terms of pa by giving summation of all xi less than equal to a pxi. All right, for instance, suppose that you are having x is having a probability mass function given as p1 equal to 1 by 2, p2 equal to 1 by 3, p3 equal to 1 by 6. So here is the cumulative distribution function. Okay, that means for a less than 1, I'm going to have a value 0. For a between 1 to 2, this is the value which I got. Okay, for 2 to 3, the value which I'm having is 5 by 6, and for less than 3, I'm going to have the value as 1. Okay, so please don't get confused over something. Only the point is I'm talking about a countable or discrete set of values. countable or discrete set of values. That's what I'm talking about. So for discrete random variable, I need to consider probability mass function. Okay, PMF, probability mass function. And if I'm going to apply cumulative distribution function over this PMF, okay, so it is defined by a summation of all xi less than equal to a pxi. Whatever be the probability of this value is, that's what I'm going to write. For instance, if I'm going to have 1 p1, its probability is 1 by 2, p2 its probability 1 by 3, p3 its probability 1 by 6. Okay, so if I'm going to define the cumulative distribution function of it, so this is what they have been given in the form of a range. Okay, a less than a 1, and then between 1 to 2, then between 2 to 3, and less than 3 here. Okay, so just focus upon what's been told to you. It's a discrete random variable, that means something which is countable in nature. Okay, and it's defined as like probability mass function in this thing. Okay, and no need to just think over that, sir. This is certainly an example. Okay, fa equal to summation of all this thing, it's just certain given an example for you. For this p1, p2 and p3, you need to focus upon this function only. That means I need to look out for a probability mass function, and this is given by pxi. Probability mass function is given by pxi, and whatever be the values of xir, whatever be the values of xir, I need to calculate the summation of all of them to get the cumulative distribution function. Okay, so whatever be the values of x, it will be given to you. No worries in the problem statement. X equal to 1, x equal to 2, or x equal to whatever be the thing is, it's been given to you. And its probability here, for p1 it's 1 by 2, p2 it's 1 by 3, p3 is 1 by 6. So 1, 2, 3, these are discrete values, you know that. These are discrete values, and its probability, it's given in the question itself. Okay, p1 is 1 by 2, p2 is 1 by 3, and p3 is 1 by 6. So I need to take the summation of all of them for your cumulative distribution function. Okay, it's here, it's mentioned in the formula. Okay, however, I'm not proceeding, or I'm not going into the depth, just to have an idea of this. What does this cumulative distribution function means? What does this your discrete random variable means? Okay, so discrete random variable, any random variable which is defined in a form of counting. Okay, that's a discrete random variable. Now, we also discussed about Bernoulli random variable. Okay, and it's one of the important concept. For example, we have been given a trial or an experiment whose outcome can be classified either success or failure. That means I am available with a binary outcome. Okay, and here, if we let x equal to 1, x equal to 1, if the outcome is success, and 0 for the outcome is failure, that means you are defining from your side 1 for success and 0 for failure. So the probability mass function of x is given by suppose if we say x equal to 0, that means failure, the probability of failure is p, and the probability of success is x equal to 1, then the probability of success will be obviously 1 minus p, because overall probability is between 0 to 1. If we say one of the event is having a probability p, then obviously another event is having a probability 1 minus p. Okay, so thing is quite clear. All right, so the random variable following the equation, random variable that is following a Bernoulli concept, it's said to be a Bernoulli random variable. So here is the concept for the Bernoulli. I got two outcomes. One is the success, one is the failure. I said success equal to 1. Okay, and I said failure equal to 0. And for the failure, I got the probability as p. So what is the probability of the success? It's obviously 1 minus p. So a variable which is following this concept is said to be a Bernoulli random variable. Okay, that's related to the Bernoulli. Okay, and then we are having binomial random variable. Now, what does this binomial means? Again, an important concept. Suppose we are having an independent trial. Okay, that means I'm talking about the independent events which are not dependent upon each other. That means if I do something and then it's going to reflect on any other event. No, that's not like that. I'm available with the independent trials. Okay, each of which results in a success with the probability p and a failure with probability 1 minus p. Okay, that means the probability of success is p, and probability of failure is 1 minus p. Okay, it's defined in the statement. Now, if x represents the number of success that occur in n trials, what does it mean? You performed n trials. Okay, you performed n trials, and x is there, who is going to, out of n trials, x represents the number of success. Okay, then it is said to be a binomial random variable with the parameter np, and the probability mass function of a binomial random variable parameters np is given by this function pi equal to ni p to the power I 1 minus p to the power n minus I. Okay, where the value of I is from 0 to n. All right, that means we have checked this thing somehow what above. Then in that particular case, we were tossing a coin n times, and we are saying at that we will only stop, or we will say that the outcome should be head. So you toss the coin for the first time, the outcome came head, you said okay fine, I am successful, and the probability of head was p. Okay, for example, you toss the coin for the two times, and in the first case you got tail, that means you failed. Okay, then again you need to toss the coin, and then if you got head, so the probability was 1 minus p into p, that you have seen above only. Same thing is happening here for your binomial random variable. Okay, so overall, you are having what, n number of trials. So probability of coming some event is p, success is p. So the probability of the failure is 1 minus p. Okay, so this is how I'm going to write it into a formula of binomial. You know that this is a binomial formula, and we have seen this thing into our permutations and the combinations when we were studying in our 11th standard. Binomial distribution, this is a formula for binomial distribution, and I'm writing the same for it. There is no maths which I have included from my side. This is binomial distribution only. All right, so the same concept is applicable, where ni is equal to n factorial upon n minus I factorial into I factorial, and you know that this is ncr, or I have written I here, so it's ni. Okay, so permutation is n factorial. Okay, and what is combination, n factorial upon n minus r factorial into r factorial? That's what I'm writing here. Okay, so whatever be the number of trials are, okay, you took n trials, out of n trials in I trials, I got success, and remaining n minus I trials, I got failure. So this is what the binomial distribution works for. All right. Geometric random variable. Okay, again the same thing. You are available with the independent trials, and the probability p of getting success. P is the probability of getting success. Okay, so you are continuously trying unless and until you are not getting the first success. Same thing is here also. Okay, you are continuously trying unless and until you are not getting the first success. And we have seen one problem, that's what I have already explained to you: tossing a head, getting ahead, tossing a coin. Okay, so the geometric random variable with a parameter p is given as 1 minus p to the power n minus 1 into p. Okay, it's geometric. All right, so x equal to n, that means this is a random variable. X equal to x is a random variable, and you're taking n attempts, n trials. Okay, and then you are waiting for the success to come. For example, in the first attempt itself you got success, and the probability of success is p. Okay, so n equal to 1, in the first attempt you got success, so if I put 1 here, so 1 minus 1 is 0, so 1 minus p to the power 0 is 1. So that means in the first attempt itself I got success, so I got the value as p. That is the probability of an event. Okay, if you haven't got it, you need to continue according to this formula. Okay, so this is geometric random variable with a parameter p. P is your probability of the success, and 1 minus p is the probability of failure. Okay, and this is how you need to perform. Okay, Poisson random variable. Poisson, what does this mean? Here I am having a random variable taking just one of the values, or 0, 1, 2, whatever be, is said to be Poisson random variable with the parameter lambda. For some values of lambda greater than 0 is written like this: e to the power minus lambda, lambda to the power I upon lambda upon I factorial. This is Poisson's distribution. You need to remember. Very much important. Any random variable on one of the values, any of the values it can have, is said to be a Poisson random variable with a parameter. There is a parameter also available, lambda. Okay, so accordingly, you are going to get the value for the Poisson distribution is e to the power minus lambda, lambda to the power I upon I factorial for value of I is 0, 1, 2, 3, 4, 5, 6, 7, 8, whatever. Okay, so these are what random variables which are defined over the discrete values. Now, if I would say continuous random variable, continuous, what does this mean? That means I can have fractional values also intermediate. There will be many values intermediate between the two limits. Okay, so for example, I am having x that will be a random variable x which is continuous in nature. Okay, if there exists a non-negative function f of x between the real numbers minus infinity to plus infinity, is defined as integration of f of x dx. Okay, integration. So f of x is a probability density function, that is PDF, probability density function. So it can be any function. Okay, and here this is also certainly a function. This is also certainly a function. Okay, all these are the functions. These are all function. Similarly, here also in case of random variable, f of x is a function where x is an independent variable. X is independent variable here, and I'm performing the integration. Why I'm performing the integration? The reason is I can have any number of values between the range, between that particular limits. So that is why I need to perform the integration over it, over this particular function. All right, in case of discrete values that was not the case. In case of discrete value, I am having 0, 1, 2. Here also the same thing. I was just talking about the success and the failure in case of all these, whether I took binomial, whether I took Bernoulli, whether I took your geometric, whether I took your Poisson distribution. I was talking about the discrete values. Okay, but here I am talking about your continuous random variable. So continuous something which can take any value between the your limits. So I need to perform the integration here. Okay, so as per the formula of your integration, okay, so the result which I'm going to get here is integration of b f of x dx, where f of x is the probability density function for a random variable. It is compared with the probability mass function in case of discrete. So in case of discrete, as I already discussed above, we are available with the probability mass function. But in case of continuous random variable, I am available with probability density function. Okay, so let us have some more discussion about PDF, because it keeps importance. So PDF is defined as a function of a continuous random variable whose integral across any interval gives a probability that the value of the variable lies within the same interval. Okay, that means I'm going to perform the integration. That's what I told. And the definition itself says the thing which I told you in a mathematical format. That means I need to perform integration across an interval. I already told there is an interval between this limit to this limit. I need to perform the integration. And why continuous? Because obviously you are having multiple values between these interval. So I perform integration, and it gives a probability that the value of the variable, that means there is a probability, chance, that means th- I am going to calculate the probability that between this interval, if I am going to solve the equation, the result which I am going to get will be lying between the same interval. I hope you, if you understood my English, what I said in a simple term, you are available. This probability density function is a function. I need to perform the integration over a limit, okay, over an interval. And after applying the integration, the result which I'm going to get, this interval is going to give me the probability. And whatever the result which I'm going to get, this value, that will also lie in the same interval over which I have performed the integration. That's called as probability density function. You need to make it a point. Very important. PDF, probability density function. All right. So the integral PDF from minus infinity to a value b gives the probability of a random variable to be less than b, and that's what we call as cumulative distribution function. Okay. So we can have a cumulative distribution function also. Cumulative means, that means from certain limit, na, between certain range. Okay, so if I'm saying that probability density function defined over some fixed limits, for example between a to b, then it will be automatically converted into cumulative distribution function. Okay, it will be converted. So here if I take minus infinity to b, then it will be is called as a cumulative distribution function. In general it is called as probability density function. But if you do consider the limit as between a to b, or if I would say minus infinity to b, then it's converted into cumulative distribution function. Okay, in cumulative distribution you have seen, okay sir, less than 0, okay, this value, greater than 0 to between 1, okay, this value, more than 1 to 2, this value, and more than 2, this value. That means I have organized the function into various intervals, and between these intervals, these are the values which I'm getting. So that is cumulative distribution function, CDF. Okay, now the probability of x between a range can be obtained by integral over PDF. That's what I have told. So here it is. Probability of a value between a to b is said to be integration from a to b f of x dx. This is probability density function, and x is a continuous random variable. Continuous random variable. All right. So I'm going to take between a to b, integrate it from a to b, and whatever the result I'm going to get now, that will also lie between a to b. Okay, the result here, that will lie between a to b only. All right, so if we let a equal to b now in the preceding form, then obviously integration over the same limit value, no, it's going to be 0. Just understand this concept we already know in maths. Okay, if I'm going to integrate over the same thing, obviously it's 0. Okay, so here is the general formula for probability density function between the limits a to b, integration a to b f of x dx. All right, now a and b, if these two equations are that means if it's equal, that means it clarifies that the probability for a continuous random variable will be assumed to be 0. Okay, now uniform random variable, what does this mean, uniform random variable? See, x is a uniform random variable on an interval alpha beta if its probability density function is given by this much. Now I'm specific to something. Okay, what does it specify? uh, a random variable is said to be uniform if its distribution is between 0 to 1. Okay, so this is how you need to prepare a function for uniformly distributed random variable. Okay, you're going to get the value 1 if the value of x is between 0 to 1. Otherwise you are going to get the value as 0. That's it. This is your uniform random variable. All right. So the thing is, you need to remember the function which has been defined in the maths. Okay, and just remember how much possible you can. But few basic things are very much mandatory to understand, to know. If you are dealing with the discrete variables, so you were performing what kind of operations for the discrete variables? Okay, that means Poisson and geometric, then binomial, and then you were performing Bernoulli for for discrete values. These were the operations. When you were dealing with a continuous random variable, then you should know, sir, I need to work upon probability density function, because here in case of a discrete, the function which you were studying was cumulative distribution function, CDF. Okay, and here at the continuous you need to perform probability density function. All right, so here is a formula, and there is one more thing, random variable, uniform random variable. That means its function is like this: between 0 to 1, if the value of x lies between 0 to 1, its value is 1. Otherwise, whatever be the value of x, what is positive, negative, and or whatever, more than 1, less than whatsoever, now it's 0 only. Otherwise, okay. Now, exponential random variables. A continuous random variable. See here, this case is also for the continuous. Remember, I'm not talking about the discrete. If I would say something between 0 to 1, na, so it can be 0.1, it can be 0.2, it can be 0.315, it can be 0.612, whatever. So its value will be 1. Remember, it's a continuous distribution. Okay. Now next thing is exponential random variable. So the exponential random variable is again a continuous random variable for a given some parameter, that's lambda greater than 0 is given by there is a parameter lambda is given by lambda e to the power minus lambda x if the value of x is greater than equal to 0, whatever it may be. Okay, 0. 0.1, 1.5, 10.7, 20.8, whatever, if it is greater than 0. So exponential random variable will be lambda e to the power minus lambda x, and 0 if the value of x is less than 0. So for example, if it is minus 6.5, 0. If it is minus 7.8, 0. If it is minus 100.102, it's 0. Whatever the values which are coming less than 0 now, it's always 0. It's an exponential random variable. All right, so you need to remember the formula is lambda e to the power minus lambda x for positive values. For negative values, it's 0. Okay. Now, the CDF for exponential random variable is calculated as it's written like this: f of a is 0 to a lambda e to the power minus x minus lambda x dx. So, if I do perform the integration of it, okay, if I do perform the integration, I'm going to get the result as 1 minus e to the power minus lambda a. So, you can perform the integration. Say lambda is constant here. You can take lambda out, and then you can perform e to the power minus lambda x integration with respect to dx. So the integration of e k power x only. But here the problem is you are having a minus lambda x now, so you know how to perform the integrations. Okay, so the result of this, that means here I'm going to perform, or I'm going to calculate the CDF for this function. Which one? Your exponential random variable. So the result which I got is 1 minus e ki power minus lambda a for a greater than equal to 0. This is your function value. Okay. So after this exponential random variable, I am having gamma random variables also. Now things are getting a bit complicated. However, it depends upon you how much knowledge you want to keep for these variables, this distribution. Okay, because the point is we are going to calculate the random variable now. Random variable. See, focus upon what we are performing. We have been given a problem statement. In initially, the value of random variable was discrete in nature, so we perform binomial, Bernoulli, these kind of approaches. Okay, and then when the value of your random variable is continuous in nature, then you changed your approach. You change what kind of function I need to use over it. So these are the functions which are applicable over continuous random variable. So one of the another variable is gamma random variable, and the formula for the gamma random variable is e to the power lambda e to the power minus lambda x to the power alpha minus 1. And this is something formula, let me alpha. Okay, and here the value of x should be greater than equal to 0, and 0 if the value of x less than 0. Okay, so here is a quantity alpha. Okay, in the gamma function there is a quantity alpha in the gamma function whose calcul there are two parameters alpha and lambda here. Okay, this is quite complex gamma random variable, no? So it's quite complex in nature. All right, so here's a quantity alpha. Actually it's called as gamma though we call in our terms it's alpha. It's a gamma function whose value is, this is the gamma function, this gamma function whose value is 0 to infinity e ki power minus x to the power alpha minus 1 dx. Now the thing is, if you want to remember you can, if you don't want it, that's okay. But the thing is, I just providing you this name, okay, and the formula for your understanding, so you might be knowing that what are the possibilities, how many types of continuous random variables are. Okay, so one of them is your gamma random variable. All right, now another thing which is important, normal random variable. Okay, so what exactly we are meaning with these terms? Again, I just want to point out some important things. Discrete, continuous. Okay, actually we are talking about the distribution of the data. If your data comprises of discrete values, okay, so how they are distributed in a plane. That means if I need to plot those points in a plane, what will be the kind of distribution? So it's been defined by these functions. Remember that. Just focus what I'm saying. If I need to plot those points in a plane, these functions are defining them. Okay. And if I'm available with a continuous distribution of the data, so what is this random variable? Random variable is a variable which will come out of any of the value, which will come between these limits. Okay, so if I'm talking about continuous, so that's a distribution of the data in the plane. And random variable is defined over a function which will come up over this function, according to which this data is distributed. According to which this data is distributed, a random variable will pick up a value, which pick up some certain value over the limits for which this function has been defined. Okay, so we were doing the same thing, because statistics probability plays a major role. As I told, you will be available with the data, you need to apply the data to your machine learning models. Okay, so before that, you should be knowing, you should have a complete knowledge of the data. If you're having a good knowledge of the data, that means your data science is, at the same moment, if you understand the data, as I told previously also, someone who understand the data is a scientist, and who doesn't understand data, he doesn't know anything. So data is important here. Okay, your next is normal random variable. Now what is this? Again, I'm talking about the distribution, how this data is normally distributed in a plane. So x is a normal random variable, or simply x is a normally distributed data with parameters mu and sigma, if the density of x is given as 1 upon square root of 2 pi sigma e to the power x minus nu upon 2 sigma square. Okay, so this is a formula for normal distribution. Understand, mu is a mean of the data points, sigma is the standard deviation. We will be studying about these things also in the statistics, though we are dealing currently with the probability. So I'm just giving you right now the description of the probability terms, but you need to think over that. Okay, my data is distributed according to this formula, and if I am having this formula, that means it's a normal distribution. Okay, so normal distribution here, this is mu, that means the mean of the data. Here sigma, that is a standard deviation, that means standard deviation, or I would say variance. This means the distribution of the data itself. Mu is the mean, and sigma is the standard deviation. So this is how the formula says, and the value of x lies between minus infinity to plus infinity. Okay, and it's a bell shaped structure. Here it's a bell shaped structure. This is normal distribution. Okay, so if I am available with the data set, okay, and if I apply the concept of if I am going to check what is the distribution of the data, I perform histogram. I draw the histograms for the data set. And if I'm going to find this kind of curve, oh, I will say, okay, this data is normally distributed. Normally distributed means you can see where the mu value, here is the mu, this is the mean value. Okay, so the mu, the density is, it's both the sides are same. Left of the mean, right of the mean, the distribution of the data is same. Okay, so most of the data is concentrated near to the mean of the data. And the data points which are away from the mean, it's been shown here. Okay, this point is away from the mean, this point is away from the mean. So in case of normal distribution, someone will ask you the question, come on, stand up and say, what do you mean by normal distribution? You will say, sir, in case of normal distribution, na, most of the data is concentrated towards the mean of the data set. Okay, and here is it's having a bell like structure. So here is a bell like structure, and you can see the data density is been here more in towards the mean. And apart from the mean, if I go to minus infinity, if I go to the plus infinity, you can see that the density is reduced. That means here I am having less data. That's what you should have an understanding, proper understanding. Okay, very much important. Normal distribution, I gave you the formula, I gave you the structure. of it. So it's an important factor for the normal random variables. If x is normally distributed by the parameters nu and sigma 2 or sigma square, whatever you are saying, then y equal to alpha x plus beta is normally distributed over a parameter alpha nu plus beta, and alpha 2 sigma 2 is provided by like this. Okay, just giving a formula for the normal distribution of the data. Okay, so here y less than equal to a, and I'm putting the equation of y, that is alpha x plus beta less than equal to a. Okay, and here I I perform, I brought beta here. Okay, so beta will come up here, it will be a minus beta, and I put alpha down. Okay, so alpha will come here, so x, that is a random variable, its value is less than equal to a minus beta upon alpha. So it will overall it will be the function of a minus beta upon alpha, and I will put the value of a minus beta upon alpha in place of x in this formula. In this formula, here is a formula. Instead of x, na, you put the formula of this value, this. Okay, so my limit was from where to where? From minus infinity to a minus beta upon alpha. So I'm going to put it here. I'm going to put it here. Okay, and here is what I'm getting: 1 upon 2 pi sigma e to the power. This is my same formula. Okay, and on solving it, just whatever be the on solution, this is the complex equation which I'm getting. Okay, so if you have been given a problem y equal to alpha x plus beta to check whether it's normally distributed over a alpha nu plus beta, and this thing, between this and this, you need to check out. Now for that purpose you need to prepare a function according to it. So don't get confused, it's not at all a hard or a complex thing. It's in a simple terms, this is the function which I have been defined: py less than equal to a. Okay, py less than equal to a, and I put the value of y here, alpha x plus beta. Okay, alpha x plus beta, this is the value of y. I put it here, I did some simple maths. Okay, and this is my function, and I put this value of function here in the integration, and that's it. Okay, this is how I'm performing the calculation. We are not going to do any maths here, just a simple example I gave. You should be understanding, only the point is you should understand what a normal distribution means, and which variable I'm going to say it's a normally distributed variable, normal random variable. Okay, so here is the formula for the normal distribution. This is also called as Gaussian distribution. Remember, it has two names: normal distribution or Gaussian distribution. If someone say what is normal and what is Gaussian, don't get confused, both are same. Okay, and here's the formula for Gaussian or the normal distribution and bell like structure. Okay, you know the concept, where is the density of the data lies. All right, expectation of a random variable. What else we are expecting from a random variable? See, expectation of a random variable x is a weighted average of the possible values of x that can take on each value begin weighted the probability x assume that particular value. Okay, now what does this mean? Expectation of a random variable is a weighted average. It's a weighted average of the possible values of x. That means whatever be the possible values of x, whatever be the possible values coming for this your random variable, I need to calculate the average of them on each value begin weighted by the probability that x assumes that value. That means I'm going to take the average of each and every random variable, whatever the value it's coming for, but based upon the probability. What is the probability? But each value begin weighted by the probability that the x assumes that value. That means that value is coming, I'm going to take the average of all those values, but according to the probability. What is the probability that that particular value I'm going to get as an output? That is the expectation of a random variable. And we were studying the same throughout in our lectures till now, same thing, expectation only. Okay, and I told that expectation is something that will expectation of a random variable is that value should be coming in between the limits, whatever be the limit is, are limits are defined. in between those limit only now I'm going to calculate the probability of occurrence of that particular value. That is the only random variable, that's the expectation. Okay, so if I define it for the discrete case, for example, if x is a discrete random variable, okay, having a probability mass function, you know that in discrete I'm having probability mass function pmf. Okay, and in case of my continuous I'm having probability density function, so mass and density. Okay, so here I'm having probability mass function. So the expectation is Ex equal to sigma x px. Here's the formula for discrete expectation for a discrete random variable. Okay, uh, for example, let us consider something. When we are going to roll a fair die, okay, when we are going to roll a fair die, probability of getting 1 or probability of getting 2 or probability getting 3, 4, 5, 6 is all same 1 by 6, is all same 1 by 6. Okay, so if we obtain ex, now ex, okay, why I took an example of rolling a die? Because you know that rolling a die will never give you 1.5. In die you are having 1, 2, 3, 4, 5, and 6. You don't in a die do you have 1.5, 2.7? No, you are going to get a discrete value only in case of die. Either I would say, if I'm going to toss a coin, either you are going to get head, either you are going to get tail. That's it, discrete value only na. All right, so here if I roll a die, okay, and these are the probability for getting 1, 2, 3, 4, 5, and 6. So so the probability of them are 1 by 6, obviously 1 by 6 only. So the expected what my expectation is x into px. So what is x? X is 1 into 1 multiplied by its probability, 2 multiplied by its probability, 3 multiplied by its probability, 4 multiplied by its probability, 5 by its probability, 6 by its probability. The result is 7 by 2. Okay, so the number multiplied by its probability, that's what the expectation of my discrete random variable. Okay, discrete random variable. This is what my expectation is, Ex. So if you someone asks what is the expectation value, so this is the example you need to cover up, you need to understand. All right. Now, what is the expectation for Bernoulli random variable? In Bernoulli, you have seen, now, sir, either I am going to have a success, either I am going to have a failure. Sir, for success, I have defined success is for 1 and its probability is p. And sir, for failure, the probabilities are 1 minus p. And I have assigned the value is as 0 for it, for the failure. So, obviously, for 0, its probability is 1 minus p, so I multiplied 0 with 1 minus p. Plus for success the value is 1 and probability is p, so I multiplied 1 by p. Okay, so overall the result is p. This is the expectation for the Bernoulli random variable. And for binomial random variable, what you need to do, again it's I into pi. Obviously it will be same, either I will say x into px, either I will say I into pi, it's all same. So for the expectation for your binomial random variable is summation, summation I equal to 0 to n. And if I apply the formula, if I apply the formula I equal to 0 to n, okay, so here is a formula for your binomial random variable. You have seen ni p to the power I 1 minus p to the power n minus I. Okay, so just multiply I here, and I factorial is I into I minus 1 factorial. You very well know about this thing. All right, so I'm going to cross off, I'm going to cross off I. Okay, I'm going to cross off I from here. So in denominator I'm having I factorial, so I factorial will be I into I minus 1. Okay, so here above you are having I, so subtract or just cancel I from here. Okay, so in denominator you are going to get I minus 1 factorial. So this is the formula. All right, later on it's up to you, you can organize it into your any of the ways. For example, in n factorial I took n common, and I am left with n minus 1 factorial. So n I took outside, p to the power I took p common, so it will be p to the power I minus 1. So np I took outside. So here is your here is your complete equation. Okay, So expression, so here you can again re-simplify it in the form of n minus 1 to the k p to the power k 1 minus p to the power n minus 1 minus k. So it will be like this thing only. It will be later reduced to p plus 1 minus p to the power n minus 1. Finally you are going to get the result as np. See, I am not doing anything extra, I'm not doing anything complex. This is already present in your 11 standards. Okay, when you're studying your permutation and the combination, and this is a simple structure of your binomial random variable. Okay, what is the expectation? The expectation is NP. Final result which you got is the NP. All right. So for Bernoulli, it's P, and for your discrete in a simple terms, you have seen this x into p to the power px. Okay, binomial, I'm getting np. Okay, and for the continuous, what will be the expectation is obviously again I'm going to perform x into f of x dx with the integration minus infinity to plus infinity. Okay, and what was here in case here I am having summation. Remember, because I am available with the discrete values, just click the things in your mind what I'm saying. If I am going to look out for the discrete values, now need to perform summation. If I need to perform the for continuous value, I need to perform integration. So integration minus infinity to plus infinity s x into f of x. See, x into f of x was there also, here also, but here I am available with the integration. There I was available with the summation because my values were discrete in nature. Okay, so here, if I do talk about uniform random variable, just perform the integration alpha to the beta x upon beta minus alpha dx. That's what my function is. Okay, that's what my function is. So if I apply the integration with respect to it, I'm getting the result as beta plus alpha by 2. Okay, for uniform random variable, this is my result for uniform random variable. And you have already studied for uniform random variable, the value should be between 0 to 1, then it is uh, your x. Okay, and it should be 1 if your x lies between 0 to 1, so your result is 1. Apart from that, your result is 0. Okay, so the expectation is alpha plus beta by 2 in case of continuous random variable. Okay, now if I'm going to talk about the normal random variable or the normal distribution, here it is. 1 upon square root of 2 pi sigma, already a formula, x e to the power minus x into nu square by 2 sigma square dx. Now, we are not going to do in hard and fast calculations. Whatever the calculation it did, this is the result which you finally got. The result is new. So the expectation for Poisson distribution, or for Gaussian distribution or normal random distribution, the result you are going to get is a new, or the mean value. Okay, so because why? There is a symmetry. There is a symmetry. You know that in normal distribution, it's symmetric about mean position. Okay, so if I do take minus infinity to plus infinity f of x dx multiply by nu, now the result is new because this function is a symmetrical function about the mean. All right, so that's what I'm expecting from the normal random variable. So you need to just remember the things. Okay, so final result is new. We are not performing any hard and fast calculation here, though it's easy integration. Expectation of a function of a random variable, that means we know that how to calculate the expectation of a random variable. We also need to study about the expectation of function of a random variable. That means it will again depend on if x is discrete or continuous. Okay, so let us again crack this issue. That means how to calculate the expectation of a random variable function. Previously, we were studying about the expectation of a random variable. Okay, uniform random variable, normal random variable. Okay, for both the cases, discrete and continuous, we did study about these. Okay, now I'm going to discuss about what is the expectation. What is the expectation of function of function of a random variable function. Okay, so how to calculate the expectation of a random variable function? Again, I'm going to split it into discrete and continuous. So let us consider the first case of discrete. For example, if I'm available with a discrete random variable with a probability mass function, see, same thing, I'm targeting the words. Discrete, for discrete, you need to perform summation. and here your function is probability mass. In case of continuous, you need to perform integration, and your function is probability density function. Okay, so here if I'm going to look out for probability mass function, okay, discrete random variable with the probability mass function px, okay, here is the formula: summation of gx into px. Okay, previously I was just simply available with x into px. Now I am available with, because I'm going to consider for what, calculate expectation of a random variable function. I'm not talking about random variable, expectation of a random variable. No, I'm talking about random variable function. So previously, if I'm talking about random variable, I did multiplied x by px. Now, if I'm talking about random variable function, I'm going to consider one function, and that's what I'm going to multiply with the px. Okay, so gx px, that's what I did. Okay, so here is what I got in the form of a result: summation and gx into px. So suppose for example, we are available with the probability mass function like this: p0 is zero point 0.2, p1 is zero point 0.5, p2 is zero point 0.3, and I need to calculate ex square. Okay, so this is actually probability, your mass function. Okay, probability mass function for a discrete random variable. Okay, so the point is point so the how to solve it: point to into with whom, point to with whom I need to multiply. Point 2 I multiply by this thing 2, then point 0.5 I multiply by 12, and point 0.3 I multiply by 22. Now the question is, sir, from where I got this it's written like 0 to, it's written here 12, it's written 22. So from where I got these values? This is gx. This is gx, because px is point 0.2, point 0.5, and point 0.3. Okay, I am going to multiply with the gx, another function. Okay, so this 0 2, or I would say 2, 12, and 22, these are different function values over x, and I'm multiplying it and performing the summation, just performing the summation, and the result which I got is 1.7. So just you need to multiply gx with the px and perform the summation of all of them. That will be your expectation of a random variable function when you are considering the discrete case. Okay, now if I do talk about continuous random variable, okay, with the probability density, obviously. In case of discrete, I'm having probability mass. In case of continuous, I'm having probability density. And here is a formula: previously I was taking x into f of x dx integration minus infinity to plus infinity. Now I'm taking gx into f of x dx integration minus infinity to plus infinity. Instead of x only, I put a gx. Instead of x, there is a gx. All right, so now let us again take an example over uniformly distributed data between 0 to 1, and I need to calculate this ex3. Okay, so that's what I'm going to perform: integration in ex3, integration x ka cube, x cube. This is x3 now. Previously I'm having x square. Okay, x2, sorry, it's x, yeah, x square. Okay, here I'm going to take x3. Okay, so integration x cube 1 into dx, that means from 0 to 1, from 0 to 1. All right, so now here you know that I am talking about normal. So in normal distribution, you know that it this function is having, if I am having the values between 0 to 1, the result is 1. And if I'm having otherwise 0 to 1, the result is 0. So it's already defined to you, it's already given to you that this function is having the values between 0 to 1, so the result is 1. So gx is x cube, fx is 1. So gx into fx is x cube into 1, integration dx, so it will be x cube ka integration, that will be x to the power 4 upon 4. And I need to put the values from 0 to 1, so I can put it, the result which I'm going to get is 1 by 4. This is simple. The result which I got here is 1 by 4. All right. So easy terms, these are easy terms, not at all that much complex. Just only things is you need to understand. And what I'm doing here, it's just I'm just calculating the distribution of the data defined over the functions. Okay, that's what it means. And usually if you ask to someone, and if you refer to some any of the materials, it's always taught, okay, math is difficult for data science, and we are having probability, we are having statistics, we are having calculation, we are having linear algebra. Okay, we are having all these things. But the point is, you should be good in maths, and you have done a lot of calculation, you did studied all these things previously also. Okay, it's not something fully new to you. You know that what is probability, what are different kind of probability functions are there, you know what is discrete, you know what is continuous. So we need to apply the same concepts here also. Fine. Now let's proceed ahead. The expected value of the random variable ex is referred to the mean for the first moment of x, and the quantity e x to the power n for n greater than 1 is the nth moment of x. Now what does this moment has been telling to you? The expected value of a random variable x is ex. Okay, is ex. It is also referred to as a mean or the first moment. Okay, so ex is referred to the mean or the first moment, and the quantity ex to the power n, where value of n is greater than 1, is said to be the nth moment. Just you need to remember, or just go through this line. What does it say? Okay. Now, variance. What does this variance means? Important. The variance x measures the expected square of a deviation of x from its expected value. So variance is the deviation. Remember, very much important. Standard deviation and the variance. These two terms are important in terms of your statistics. So variance is measured as an expected square of the deviation of x from its expected value. So this is your x is what your random variable. If there's a deviation of this value of the random variable from its expected value, that's called as a variance. See, variance na, variation, change. Ultimately the English word itself means the same na, variation, change. That's what the variance is. So the variance of x, it measures the expected square of the deviation. So here it is, x minus ex ka square, that is called as a variance x. So x minus ex ka square is the formula for the variance. Okay, so it's used to calculate the variance of any distribution. Now variance, you should be remember, someone asks what is variance, we'll say, sir, variance is the it's a measure of the expected square of a deviation. That means I'm going to have a random variable, and I'm expecting where it should have to be present, but if it is not, so I'm looking forward to find the deviation. Okay, from where this point is deviated from my, or in my plane, where this point is present in my plane. Okay, what's the distribution, or what actually the shift of this point in the plane. Okay, so the variance is your expected square. I'm going to take the square of the deviation. That's it, square of the deviation. That's what it's told for. All right. Joint distributed random variables. Now, joint distributed random variables, see, here, uh, for example, you are available with two random variable x and y. Till now I was only discussing about a random variable x. Now if you are available with two random variable x and y, that is called as jointly distributed random variables. Okay, so if I am available with the two random x and y, so the joint cumulative probability distribution of x and y is given as like this: p x is less than equal to a, y less than equal to b, and the value of a and b is lies between minus infinity to the plus infinity. Okay, previously I was having only x, so I told the value of x is greater than more less than b, and the value of a and b is something minus infinity to plus infinity. But here I'm changing the equations. All right. So the distribution of x can be obtained from the joint distribution in such a way that, like this: fxa, that means I'm talking about x, it's written as x less than equal to a, that is equal to s less than equal to a, and here I need to consider y less than infinity. That means the value of function will be between a to infinity. And for b, that means if y b, the probability will be py less than b, and its value will be like f infinity b. Okay, f infinity b. So I'm considering here a infinity, so it should be here infinity b, because the thing is overall your x is less than equal to a, y is less than equal to b. Okay, so that's what I considered less than a, here I considered y less than b, and this is how I distributed for both x and y. Okay, so in the case where x and y both are discrete random variables, too convenient to define the joint probability is in such a way that it should be written like this: px equal to small x, capital Y equal to small y. This is the joint probability for your random variables in case of discrete. Okay, x equal to x and y equal to y. Okay, so the probability mass function is defined as pxx equal to pxy. Okay, pxy, this is probability mass function. Okay, previously I was just taking px. Previously my probability mass function for the discrete random variable x was just simply summation of px. Now I am having pxy, that's what I am taking, pxy. All right, so this is with respect to x, and this is with respect to y. Similarly, x and y, it should be like this thing only, summation of pxy, summation of pxy. Okay, so here for the discrete, I'm going to take the summation of the probability of x and y both. Okay, previously I was just taking the summation of px, okay, for one probability distribution, that means for one variable x. Now I'm having two variables, so I'm taking p, x and y both in combined, and I'm going to take the summation of them. Okay, in case of your continuous value, what will happen for a continuous value? If there exists a function f of x that is defined over all the values, real values x and y. Okay, so here for the continuous distribution, I'm going to have like this: your x belongs to capital A, and y belongs to minus infinity to plus infinity, and this is how you need to perform the integration: f of xy dx dy. Okay, that means there will be partial integration. Okay, with respect to x also, with respect to y also. Previously I was having a formula minus infinity to plus infinity f of x dx. That was the formula for my your continuous distribution of a random variable, minus infinity to plus infinity f of x dx. Now I am having a formula minus infinity to plus infinity f of xy, f of xy dy, if I'm going to consider f of xx, and fyy if I'm going to consider for fyy if I'm going to consider for y, its formula is minus infinity to plus infinity f of xy dx. Okay, and in combination it's written as f of xy dx dy, f of xy dx dy. Okay, so don't be confused. Just add one more variable which you did studied for for your one variable x. Just you need to add one more variable. Previously, in case of discrete, I was having px only, summation px. Now I am having summation pxy. And in case of continuous, previously I was having integration minus infinity to plus infinity f of x dx. Now I am having minus infinity to plus infinity, then one more additional integration. Okay, because there are two variables x and y, so here I am having f of xy dx dy. Okay, and then if I go separately with x and y with respect to them, so this is what I'm going to get: the joint yeah, this is the joint probability, and this is your for x and for y. Again, it's joint in nature only, but I separated just for x and just for y. Okay, if I'm going to study about what are the expectations for the jointly distributed random variable in case of discrete, so here is the expectation. Okay, just you need to perform the summation. Okay, and here you need to perform the integration. Jointly distributed random variable, for the function. So previously for joint for expectation of a random variable, you were doing what? In case of discrete, you are doing, sir, summation of x into px for discrete, and for this continuous, you are doing, sir, integration x into f of x dx. That's what you are doing. Similarly, here also we can include, or we can update our formula. For joint, I'm going to take g of xy into p of xy, random variable function. I'm going to consider random variable function. So here I can take g of xy, p of xy, summation for the discrete, and integration g of xy, f of xy for the continuous. That's what I can take. Same thing, not a difference. All right. Now, if I now again move up the formula and apply it here for this ex plus y, so it will be equal to ex plus ey. Okay, previously I was calculating only ex. Now this is the joint probability ex plus y and performing the integration. Okay, if I'm having a function, for example, gxy, this is the function given to me in case of continuous case. For example, I'm just considering, okay, if my gx function is x plus y, so I can put here x plus y f of x y dx dy. So it will get distributed. Okay, and this is the result which I'm going to get, ex plus ey. So e of x plus y is equal to ex plus ey. It's a general term to remember. Okay, so it's extended to nth. It can be extended to nth. Okay, so here that's what they did. E a1 x1 a2 x2 an xn, that will be equal to a1 ex1 plus a2 ex2 and so on. It can be extended. Okay, now independent random variables. Now what are these? Previously we are talking about dependent variables, now independent random variables. We were calculating the joint probability, now they are different. See, the random variable x and y are said to be independent for all a and b, if the probability of x less than equal to a and y less than equal to b is equal to the probability of a and probability of b. So they are independent of each other. So if I'm going to consider x and y, these two things, so the resultant probability which I'm going to get is the multiplication of pxa and pyb. Okay, this is what the probability I'm going to get. Fine. So the thing is, in terms of joint distribution function, f of x and y, we are having x and y which are independent of each other. So this is what we can write: fab equal to fxa into fyb for all a and b. Okay, that means ultimately you not have to get confused with the equations. Don't confuse with the equations. Only the point is, just let me write you here in a simple terms. What is the expectation? For example, you are having two independent variables. Okay, random variables. So the probability of both of them will be probability with the probability of a. Okay, for example, you are having a and b. These are the two random variables. So it's been asked you what is the probability of these two random variables, independent random variables. So just you need to say the probability of a multiplied by the probability of b. This is the probability of these two random variables. That's it. That's a independent cases. All right, and it's very much important to understand. Okay, because in most of our studies we are going to use it. That's what it's mentioned here in the formula, and that's what I have written here for the two independent variables. This is the probability. Okay, just multiply them individually. All right. So if x and y are independent to each other, here is what I got: egx into ehy. That's the result which I'm going to get. Now, important terms, important things. Previously, we did discussed about your variance. Okay, here I talk about the variance, and we came to know that variance is the difference. It's a deviation. Okay, that means it is the expected square of the deviation of x from its expected value. Okay, so here is what the difference of the square which we calculated. Here I got one more term, one more important term, that is called as covariance. Again, very much important, you need to make it star. Covariance. See, covariance of any random variable x and y is denoted by covariance of x and y, and it is defined as ex minus ex, y minus ey. Okay, that means multiplication of these two, x minus ex and y minus ey. This is called as a covariance of x and y. Okay, and then further you can have a multiplication of them. Okay, further you can have a multiplication x into y, then x into ey, then I am just here multiplying these two brackets. Okay, and that's what I'm going to get here at the last. Okay, after multiplying and just solving this equation, the result which I got finally is exy minus of ex into ey. Okay, so the covariance of x and y is e x into y, that is the expectation of x into y minus expectation of x into expectation of y. That is the covariance of x and y. All right. So it's a very much important term, covariance. So the variance and the covariance both are very much important terms. So covariance of the two random variable x and y is defined over this thing. Okay, so you need to you need to remember these things. Okay, what I have written here, x minus ex, y minus ey. Okay, and at the last, if it's possible, then it will be great if you remember the formula which I'm getting. Okay, that means covariance of xy is exy minus ex into ey. That means individual multiplication. So remember, if the two events are independent of each other, so if someone asks what is the probability, so you will say, sir, the probability is, now if two events a and b are there, they are independent of each other, so the sir probability is pa into pb. Joint probability is pa into pb. Okay, now if someone asks you what is the covariance of these two events, so you will say, sir, the covariance is e x into y. That means if I would say ab, so it will say eab minus ea into eb. This is the covariance. Okay, and what are the properties of covariance? See, covariance of x is variance x. Covariance xx is variance x. Covariance of xy is equal to covariance of yx. Okay, it will not impact. Okay, if I reverse the variables now, it will not impact. And if what is the covariance of c, if I multiply the variable with some value, okay, so it will come outside. Covariance of c x y is equal to c covariance xy. And if I'm going to have addition like this, covariance x y plus z is equal to covariance xy plus covariance xz. Okay, that means x will be distributed over y and over z. It will be distributed over both. All right. So here is the covariance properties. Very much important. Variance and covariance are very much important. You need to remember both these terms. Okay, and what I'm talking about variance and the covariance, I'm talking about the distribution in the data. Variance, you told, sir, there is a deviation from its actual position. How much is the deviation? I'm going to tell with the variance. Okay, and covariance, co people, it's which people I said to be co-authors. That means there are two people. Okay, so obviously x and y, these are the two variables. Just simply remember in your mind, don't stress it up. Okay, so here's the property and here's the formula. That's it. Okay, now next, very very much important, very much important again, Bayes theorem. Because in case of machine learning, we are available with the Bayes model. Okay, so Bayes theorem is something which is very much important. You need to just uh, focus Bayes. Okay, and I will help you in understanding this Bayes theorem in a very simple terms with the help of a set theory. Okay, so for example, you are giving two set, you have been given two set, a and b. These are the two set available to you. All right, so how to calculate the intersection of these two set, pa intersection b? How to calculate the intersection? It's already been shown to you. Okay, so this is your a, this is your b. A intersection b is the shaded region that is in between a and b. That's called as a intersection b. So the formula, here for a intersection b, is given as PA by B into PB, and we have already studied about the conditional probability in our previous lecture. Conditional probability AB is said that B is occurred and I am looking forward for A to occur. The probability of B, that means I need to calculate the probability of A actually, and B is already occurred. You have seen P A by B, you have already seen. You have seen this thing. Okay, conditional probability and told, sir, I am going to calculate the probability of B. In fact, B has already occurred. I'm already available with the probability of A. It's already occurred. I need to calculate the probability of A. It's a conditional probability. Okay. So here in Bayes theorem, you need to apply the same conditional probabilities applicable here. Conditional, very much important. Okay, so we know about the conditional probability. Here is the formula for the conditional probability: pa by b equal to pa intersection b upon pb, and pa intersection b is equal to pa by b into pb, and pa by b means the probability of a, and b already occurred. Probability of b, it's occurred. Okay, so here this is the formula for the conditional probability. I'm going to derive for the Bayes theorem. So we can say that P intersection B equal to PB intersection C, both are same. PA, either I will say A intersection B, either I would take B intersection A, both are same. Okay, so P intersection B is written as PA into PB by, remember here, remember, PA intersection B is equal to PA by B into PB. So B intersection A, how it's written? It can be reversed of it. It can be reversed of it. However, let's check it here. Pa intersection B is equal to pa into pb by a, and pa intersection B can again be written as pb into pa by b, because both of them are same. Okay, so this is actually pb intersection A, this thing. Okay, if you want I can rewrite it again. This is b intersection A. Okay, let me copy it and let me paste it down. Okay, this is b intersection A. That means the probability of A, here it is, p intersection B means probability of A multiply by probability of I'm going to calculate the probability of B with respect to A, probability of B with respect to A. Okay, and A already occurred. Okay, so since this is also and this is also same, so here I wrote pa intersection B equal to pb into pa by b, same thing. Now it shows that, sir, both are same. I can equate it: pb pa by b, and pa pb by, sir, equate it. So I equated, and what I did, I brought b down here. B is down here. Okay, so PA by B is equal to PA into PB by A by PB. This is called as Bayes theorem. This is called as Bayes theorem. Okay, remember, Bayes theorem is based upon conditional probability. Conditional. We are available with the two events. We are available with the two events. Okay, A and B. So the conditional probability for them is given by this thing, PA by B. This is a conditional probability. It's given as PA intersection B upon PB. That's what it's given for. All right, now I calculated what is A intersection B. Okay, here I multiplied B and I calculated A intersection B, and I know that A intersection B and B intersection A both are same. Okay, so I equated the values of both of them, and I put BB into denominator of it, PB into denominator of it. So here is my conditional, here is my Bayes theorem. Finally, PA by B is equal to PB by A into PA upon PB. This is a Bayes theorem. Okay, and it's very much important. All right, so the thing is, let us have okay, let us have some general purpose formula for the Bayes theorem. Here it is. Here it is. So here's a general formula for the Bayes theorem. PAIA, that means A has 1 to n cases. We can choose some of the cases to find the probability. It's up to you. And here is a formula. This is a normal base theorem. PAI upon PB. That means I can further distribute my formula on the basis of it. That means I can perform the summation j to I to n pba j to paj. Okay, I can further distribute my formula. Okay, so please don't get confused. Just remember only one thing: what the Bayes theorem actually means. This is what the Bayes theorem means. All right. So you need to focus upon this formula only. Pa by b equal to pba, pa upon pb. Pa is the probability of a, pb is the probability of b, and pb by a is the joint probability of b and a. That's what my Bayes theorem says. Okay. So how to remember? If someone say pa by b, okay. So what you need to do? You need to flip it here. B a by b na. So you just do it. P b a b a. Okay. And whatever be the denominator na a, you need to write it here p a, and whatever the numerator, you need to write it here in the denominator p b. That's what you need to remember. Okay, it's up to you how you are going to write it. So this is your Bayes theorem. Very much important. All right. Now some important terms. Likelihood. See, the distinction between the probability and the likelihood is fundamentally important. Okay. Because probability attaches to possible results while likelihood attached to the hypothesis. Okay, so probability is likely what I'm going to get as a result, and likelihood is actually hypothesis. Okay, it's something to be deduced. All right. So okay, probability density function I've already told. Okay, here is a probability model outcomes. Here is a likelihood. Fine. What next to be done in this? Okay, so let's check the difference between these two on the basis of the diagram. Probabilities are the area under fixed distribution. Okay, so here it is. For example, you got a curve, you got a bell curve. Here is the probability by red area. So probability is actually an area. I can have a value between of any of the variable between this particular area. Okay, that means I am having probability on the basis of data and the distribution. Okay, well, likelihood are the y-axis values for fixed data points with distribution that can be moved. Okay, so the point which is on y-axis, likelihoods are the y-axis values for fixed data points. Here it is. You can see plus the points which are on the y-axis. Okay, likelihoods are the y-axis values for fixed data points with distributions that can be moved. But here, in case of probability, it's an area under fixed distribution. Fixed distribution. The distribution is fixed. For example, I have marked this area red. I have marked this area red. So my result I'm going to get within this area only. That is the probability. That means I am having a fixed distribution. Area is a fixed distribution. While likelihood is it's not having a like fixed area. There is I'm not talking about the area in case of likelihood. Likelihood is a value, okay, which I can get or for the fixed data points. Whatever be the data points here, these are the data points, these are fixed in nature with distributions that can be moved. So from on a y-axis I am having fixed data, 5 data, 10 data, 20 data, 30 data, whatever be the data points which are available on my y-axis. I can get a likelihood over it. I'm not talking about area, I'm talking about the fixed data points. Here I'm talking about the fixed area. Okay, the area under the distribution. Okay, so within distribution, I can get anything. That's a probability. But here, in case of likelihood, I'm going to get anything with this particular y-axis points, so fixed data points. I can get any of the data. That's called as a likelihood. Okay, so here's the difference between likelihood and the probability. So in a model, I can have a probability that is based upon outcomes, and on the outcomes, I can have a model that's called as a likelihood. Okay, so likelihood, what is I'm going to get? It's a model, and probability I'm going to apply over a model, and I can get the outcomes. It's a cycle. Okay, fine. So here it is. And then what's important next? Outcome. What's important for you? Distribution. I have already told you. This hard and fast formula. It's not for you to just get over. Okay, posterity. It's not been important. Fine. Okay, so this is some concepts related to the probability. And what you need to remember, is what is variance, what is covariance, what is Bayes theorem, what is conditional probability. Okay. And what is likelihood is something which I told you right now. All right. And normal distribution, Gaussian distribution. Okay, that's what you need to remember. You need to remember binomial, Bernoulli. You need to remember what is discrete. You need to remember what is continuous. If you remember all these things, you are good in the probability section of your data science and the machine learning. All right. Now the next thing which I need to teach you is the statistics. Again, very much important concept. Let's proceed ahead with the statistics part. Okay, so now we are going to study about the statistics in data science and machine learning. Okay, so here it is. So if I do talk about the statistics now, again, it's a fundamental and it's a very powerful mathematical field. Stats. All right. So as I already told, you will be available with the data set in your projects now, which you are going to do for DS and ML. Now you are available with the data set. So what I'm going to do with the statistics, how it's important, why it's powerful, why I'm saying, because you are available with the sample data and you need to help this statistics. I'm going to get a help from the statistics to infer a population outcome. I need to calculate some outcome out of that data. What is the meaning of that particular data? That can be only find out with the help of a statistics. Okay, so population outcome. Okay, you are got a sample. I'm going to collect some data out of that particular sample. Okay, that will be considered. Uh, that's considered as a subset of the data. Okay. And whatever be the result which I'm going to expect from that particular data, that is what is the mean, what is the mode, what is the median. Okay. And what is this variance, what is this covariance, and everything, standard deviation. Okay, that's what I'm going to calculate with the help of statistics only. All right. So this data going to infer which is being used for overall impact. Either I'm going to consider the case for the forecasting or anything. So statistics is just not only a combination about some topics, but it discovers the semantics within these topics. And here are the topics which we are going to cover. That is the population in the sample. What does this mean? Variable level of the measurement, measures of central tendency, percentile, quartile, frequency distribution, and many more. There are many things we are available with us in case of your statistics. We are going to consider each and everything of them in a simple terms. Okay. So what does this statistics means? Statistics combine some techniques for drawing a reliable conclusion over a large group of data. I need to conclude something over a data. Okay, so who is going to help me to give a conclusion over the data, that this distribution of data is likely to be this thing? Who is going to give me? And how I can apply and give answer? See, I am having a large group of data. So large group of data is called as population. And I told you in my first lecture only, that you have heard about the surveys. Okay, for example, there is a survey need to be done in your city. Okay, what is the status of women in your city? So, do I need to consider every woman in your city? There might be lakhs of women in your city, that will be called as a population. But the survey is conducted on some thousand of women only. Okay, 3,000, 4,000, 5,000, and on the basis of survey, I can give some answer. Okay, the status of women in your city is this, is this. So if I do consider every woman in your city, that will be called as a population. I'm not talking about population, but I'm going to perform the experiment on small group out of population. That means I'm going to take some sample. So out of 1 lakh female, for example, if it's a population, I'm going to do the survey on some sample that is near about 3,000, 4,000. It will not be possible for me to do the survey on 1 lakh females. Okay, so I can take the sample and I can perform some conclusion. This is the state of the woman in your city. Okay, I can summarize the data set. That's the point. This thing is performed in statistics. That's the importance of statistics. So out of population, you can take some sample size, you can do experiment over it and get the result. So statistics is a discipline that concerns the collection of the data, organizing the data, analyzing the data, interpretation of the data, and presenting the data. See, I am going very simple. Okay, you need to understand it here only in this simple terms only. Okay, now if you are having any doubt, please let me know. You are quietly listening to me from long time. Any doubt, please let me know. You understood what does statistics means? Girls, is it clear what does the statistics means? That means here the simple definition has been written. You are seeing the simple definition. Collecting the data, okay, organize it, because data collection can be the data can be rough, the data can be in a rough format. Okay, so you need to organize the data into good, meaningful. Then you need to perform analysis over it, you need to perform interpretation over it, and then finally you need to present the data. That's what statistics says. Okay, and statistics is of different types. It is having two category. Remember, my each and every word is important here, because if you are going to be data science person, if you are going to be data analyst, data scientist, whatever, you should have a knowledge of statistics. It's important, mandatory. I told that linear algebra 30% contribution, statistics probability 20 to more than 20%. So 65% contribution is for linear algebra and probability statistics only for data science people. Remaining is 30 is for your other maths. So here, if you know these things, you are being skilled enough to understand the concepts. So statistics, I am having descriptive and inferential statistics. Two types of statistics are there. If I do talk about descriptive statistics, it summarizes or it describes the population or sample data set. Okay, that means summary. It gives a summary of my population, of my data. I am going to give the summary of my data. That's called as descriptive statistics. That means it is having the type of a data, variables, data representation, frequency distribution, measures of central tendency, percentile, quartile, covariance, correlation. That's what everything I need to give. So when I'm going to do the project, for data science and machine learning, I follow the approach of descriptive statistics. Okay, so whatever be present in the data, I'm going to do exploratory data analysis, EDA. I need to perform EDA. So in EDA, I give everything. What are the variables present? What is the type of data? I do prepare a plot of them. I do draw the visualizations for them. So this comes under descriptive statistics. That means summarize your data. Okay, so that's what we are going to do in our projects also. And here are the following topics which are present in the description. For inferential statistics, it is a part of stats that finds the reliable inferences of population from the sample data. For example, it covers the probability distribution, central limit theorem, and etc. hypothesis testing, etc. That means inferential statistics, I need to find the reliable inferences of population from the sample data. That means here I need to calculate something else. Okay, that means I am going to apply some test over the data. In descriptive analysis, I am not going to apply any kind of test over the data. Okay, but here in case of inferential, now I need to apply some test. That means I'm going to find the distribution, probability distribution. You have already studied the formula for the probability distribution. You need to apply some hypothesis testing, and this ANOVA and square test are one of them. Okay, so you need to check the errors, post estimate, and this I'm going to cover each and everything, each and every topic I'm going to cover here in my lectures. Okay, so if you are going to apply some test over the data, that's called as inferential statistics. Okay, and if you are just simply describe the data, that comes under descriptive statistics. And statistics is what your collection of the data, organizing it, interpretation, analysis, and presentation. That's what you need to remember. So from today's class only, you need to remember each and everything what I'm going to say over the statistics. Okay, don't forget. Now, population. Now, question, sir, what is population? I already told. In your city, if I'm going to consider each and every woman, it's a population of female. And what is sample? If I'm going to consider few thousand of the women from your city, then it is a sample size. The point is clear. So, there is one example also given. If you want to know the university student CGPA, here the experimental area covers all the students. So, if I'm going to consider all, it's a population. If I'm going to pick some students, then it is a sample size. That's it. Variable and level of measurement. What does this mean? See, variable, you know about it now. Variable is something which is very, that means which can hold multiple values. That's called as a variable. Okay, so it is nothing but the features of data set. Features of the data set. Okay, so I am available with the data set. I will be available with the data set, and my data set will be comprising of various features. Okay, so these features will be anything which is contributing, which will be the contributors. Okay, so uh, that I am having x value, I am having y, I am having dependent, I am having independent. So the features which are present in your data set, there will be all features which are independent, and there will be one feature will be dependent on that particular feature, that will be our target variable. So if in your data set you are available with 10 features, and if you are performing a problem statement of prediction, house price prediction, okay, so price is something which will be on y axis, that will be dependent, and that will be dependent feature. And remaining other feature, for example, your locality, number of bath, or I would say area, or any other, these are independent variable. That will be the features, which can be vary. All right, that we are going to see in our project sessions. And the different types of data having different features, and we must know the measurement level to understand how to deal with that particular data. So what we need to do with the data, na, that will comes under level of measurement, that I will going to show you practically when I will be present there, and when we are going to do the projects. So obviously we are going to do the projects on house price prediction. I will explain each and everything. Okay, everything, this is a variable, this is a type, and everything. Okay, central tendency, that measures of central tendency. Okay, in statistics, mean, median, mode are known as a central tendency. Okay, so mean, that, sir, take the sum of all the values and divide it by the number of those values, that will be called as a mean. It's a straightforward formula. And median is median value. How to calculate it? We need to sort the values in ascending order and pick the middle value, that is called as a median. So you sort all the values first. For example, if you're available with the data which is having five values, here it is: 12, 13, 10, 15, 7. These are the five values you are available to you, and it has been asked, calculate the median. So you need to first organize them, you need to first sort them into ascending order. So in ascending order it will be like this: 7, 10, 12, 13, 15. And median is the middle value. Okay, since it is odd in nature, so the middle value will be here, it's your what, third value. And how to calculate it? This is a formula for the median. You know that n plus 1 by 2, that means the number of values plus 1 divided by 2. For odd, this is how you can calculate the median. For even, that n by 2 and n plus 1 by 2, that will be the median. In between these two, that will be the median value. For even number, that you've done a lot of maths for calculation of mean, median, and mode. These things. Okay, it's not new for you how to calculate median. So for odd, this is how it's calculated. And for example, you are available with the even number of values. So for even number of values, here I'm not going to consider the middle value by using the same formula as I did for the odd number of values. Instead, I'm going to sum up for the third value and the fourth values. So that will be 22 by 2, that will be 11. So third and the fourth value, that's what I'm going to sum up, and that will be your median value. So these formulas you already know. So it will be like n by 2 plus n plus 1 by 2. Now mode. So mode works on categorical data. Mode works on categorical data. See this line, na, though it's looking mode 1 or works on categorical data. Now you will ask question, sir, categorical data, sir? Matlab, what is categorical data, sir? I've already explained you in the first class also. And today also I explained. You are having data that is discrete in nature, that is continuous in nature, and that is categorical in nature. So for discrete and continuous, I can apply mean and I can apply median. Okay, I can apply both of them. However, if I'm available with the categorical data, categorical means true, false, yes, no, good, bad. Okay, so this is category. A, B, it's a category. 0, 1, it's a category. Okay, so I can consider. So for categorical data, na, I need to apply mode. And what is the mode? Mode is the calculation. Na? Suppose we are having this data: good, bad, normal, good, good. So what is the mode? Mode is the value which is which is having high frequency, which has been repeated highest number of times. So good is one time, two time, three time. So the mode of this data is good. That means highest frequency value, the value which is present in the data set most of the time. That's called as a mode. That is a mode. Simple. So mean, median, mode. These are used in central tendency. So when to use the central tendency? That's a question. When to use these choices? See, when we will be doing the projects now in our data set, it may happen that your data set comprises of null values, empty values, and we never work on empty values. Okay, either we need to fill them up or either we need to remove it. Okay, so if I need to fill the empty values, I can fill it with either mean or either median if my values are discrete or continuous and they are empty. And if I am having a categorical column, categorical value, and it is having empty values or null values, I need to apply mode over it. That's what I need to proceed. That's why the question said when to use those measures of central tendency. Very much important. They are used for imputation. Imputation means filling up the values. Okay, so that's what we are going to see practically. Okay, and obviously it's important. Now next things: percentile, quartile, and IQR, interquartile range. So percentile, so you guys are having percentage or percentile? What you guys are having in your exams? Do you get percentage, percentile? Do you got grades or what kind of results you are having? Can you please tell me what results you are having? Percentage, percentile, grading system. Can anyone tell me? I hope you are listening. What kind of grades you are having? How your results has been displayed? Anyone? Okay, percentage. Fine. You know that how to calculate percentage, Divya? How to calculate the percentage? How you are going to calculate the percentage? What's the way of calculating the percentage? Okay, marks into 100. That means the total number of total marks divided by, is that you're divided by subjects also? Divide by the number of subjects. That's also be there. And then you need to multiply by 100. Is that the case? Or something else? Well, it's very much important for you to understand. Okay, marks obtained by total. Okay, marks obtained by total. Then I need to multiply by 100. That's what I'm going to get the percentage. Okay, see, I am asking to you only for your things, and you should be confident enough to answer me. So marks obtained divided by total, and then I need to multiply by 100. That this is percentage. No, I hope you also heard about this percentile thing. What is this percentile? I hope you have studied about this percentile thing also. And in case of our competitive exams, we are going to get the results in form of percentile. So percentile is a measure that is used in statistics uh, to for that means it's a percentage of observations in a group of observations. Now what does this mean? In case of percentile, what I know about the results, for example, if you are going to give the gate exam, so the person who got the highest score, the person who got the highest score, he's having 100 percentile, or gate exam or cat exam, whatever be. So the person who is going to get the highest score, he's going to get the highest percentile. And your result is calculated on the basis of that person only. Okay, so whatever the score he achieved, for example, the paper was of 100 marks and he got 99 and no one scored a 99, sorry, a 98. For example, he got 98 out of 100 and no one scored 98, so he is the topper and he is getting 100 percentile. His score is 100. And if you got 90, so your percentile will be calculated as 90 divided by 98 into 100. That will be your score, your percentile. Okay, so so right now we are getting the score, we are getting no, percentiles, not the percentage. Okay, so percentile here actually it means it is used in statistics indicating the value below which is given a percentage of observations in a group of observations fall. That means the 20th percentile is the value of the score below 20% of the observations may be found. Okay, so it's below. That's what I still na. So percentage is 100, out of 100, but I took any of the value which falls below. So 98 is the highest score of the student. So it's getting 100 percentile, and rest of those I'm going to calculate with reference to that 98 number. So if you also got 98, you are also getting 100 percentile. Someone get 97, 99 percentile. That's how the results has been calculated. So percentile is the value below which is given the percentage of observations in a group of observations for. Very very much important. Understand percentage, percentile, quartile. Now very much again these concepts know nowhere to go. Quartile. Okay. In percentile, the entire values are divided into 100 parts. Remember, in percentile the entire value is divided into 100 parts. 1%, 2%, 3%, 4%, all are been divided. But in case of quartile, now your complete 100% is divided into four parts: 0 to 25, 25 to 50, 50 to 75, and 75 to 100. That means your 100 percentage 100 is divided into four parts. Okay, 25% each. That's why it's called as quartile. Quarna, quadrant. Quar means one fourth. So 25% distribution of the data. 25% each is said to be quartile. So the main quartiles are: first quartile, that is Q1, that means between 0 to 25. Second quartile is Q2, that means between 25 to 50. Third quartile is between 50 to 75. And then final quartile is between 75 to 100. Okay, so four quartiles. And this 50% is the median value. Remember what I'm saying. Remember quartiles, distribution of the data, four parts. Q1 is 0 to 25, because this we are going to implement practically in our projects. Either I would say quartile, or either I would say quantile. Both are same. Okay, here quantile is not used, but it's same. Quartile, quantile. Okay, so quartile is your Q1, Q2, Q3, Q4. Q2 is 25%, Q3 is 50%, Q4 is 100%. Okay, so all 24 to 25% distribution of the data. Okay, so first, second, third, fourth quantile. Now IQR, what does this IQR means? IQR means interquartile range. It's IQR, interquartile range, and interquartile range is calculated between Q3 minus Q1. Here it is written Q1 minus Q3. I would say Q3 minus Q1. So Q3 is 75%. Q3 is 75% distribution of the data. Q1 is 25% distribution of the data. So 75% minus 25%, whatever is between, that is called as IQR, interquartile range. Very much important. Very much important. And here it is. This diagram, this diagram, you need to remember it, store it wherever in your hard disk. This diagram. This is the distribution of the data. And there is a box in between. Here is a box. Okay, this is Q1 25% distribution. This is Q3 75% distribution. Either I would say 25th percentile or 75th percentile, or I would say 25th quartile or 75th quartile. So here is Q1 and Q3, and Q3 minus Q1 is IQR. That's called as interquartile range. Interquartile range. Okay, and this line. This line. I got Q1, I got Q3. This is minimum value, and this is a maximum value, min and the max. And this line, blue line, is called as a whisker. The points which are available below Q3 and above Q3, below Q1 and more than Q3, these are whisker points. And those points which are below minimum, these are called as outliers. Outlier. And those points which are more than Q3, that no more than this max value, it's called as they are again called as outlier. So this is outlier, these are also outlier. Outlier are those points which are fault or wrong entries in the data set, which are expected to be according to the statistics. According to the statistics, outliers are those points which are wrongly inserted into the data, fault entries according to this statistical calculation. So this is your Q1, this is your Q2. Q1 is a 25% distributed value. This is Q3, 75% distributed value. You can see one yellow line. This is your median value. Yellow line is your median value of your data. Okay, so blue line, all the points which are present here below Q1 and Q3. This represents your minimum value. This represents your maximum value. And outliers, that means wrong entries, expected wrong entries according to your statistical workout. The minimum value, Q1 minus 1.5 into IQR. This is the minimum. This is expected to be minimum. This black line, minimum value, Q1 minus 1.5 into IQR. Whatever the value which are below this thing, Q1 minus 1.5 into IQR, they are called as outliers. And whatever the values which are more than Q3 plus 1.5 into IQR, they are also called as outliers. Okay, so very, very much important. This diagram is very much important for outlier detection. And we are going to detect the outliers in our project, and we need to remove the outliers in our project. And this is how we are going to perform. And it's called as 1.5 rule or Turkish rule. That's what I'm making you visible. All right, very much important. So, in the tomorrow's lecture, I will proceed ahead with the same diagram. Okay, and we will finish our statistics part. So, let me stop the recording first.